Let's see guys one more continuity for a different function. Continuity of function involving limit from n tends to infinity a to the power n. So you have to see this part whenever it is coming something like this way. So we have to be very take care about that where my a belongs to and what will be the value for this. A is greater than 0, infinity, and now. So based on this we have one sum. Okay, the sum is here. You can see the sum is this. You can see clearly that n tends to infinity. So when we have to solve this, we know from the limit that if we have a limit infinity, so we have to divide with the highest power of the x. So here n tends to infinity. So what I can do is I'm dividing with the highest power x. So I'm getting this part. Now the point here is, even though after getting this part, what are the values we can get here as -1 if my x square lies between the 1 and 0, and 0 when my x square is equal to 0, and 1 when my x square is greater than 1. This is very important to understand. As you can see that if I'm gonna substitute these values, my function will be discontinuous at the 1 and -1, not at the 0, because if you're putting 0 as, so it will not be discontinuous at 0. So but at -1 and 1, if you'll substitute here, so I'm going to get this value as discontinuous at 1 and -1. Very important this part. As you can see from here also, that's why I have given this part, that if we have a limit something like this, so my function will be discontinuous at the points. Okay, so first of all, whenever limit is there n tends to infinity, so we have to open the function. Basically we have to find the values of the function in this separated way, or we have to open the function completely to know the values. Now my function is discontinuous where other than 0 my function is discontinuous. Same thing here, my function is discontinuous here as 1 and -1. So we can say that plus -1 is discontinuity point. Okay.